Nodal analysis is the use of Kirchhoff's current law to find node voltages. Firstly, what is a node? A node is where two or more components meet in a circuit. What is Kirchhoff's current law? It's simply the conservation of energy law. The sum of all currents entering the node equals the sum of all currents exiting the node. This is how we form our equations for nodal analysis. We can use Ohm's law to replace I with voltage at positive, subtract voltage at negative node, divided by the branch resistance. From this equation, we can determine our voltage variables. Let's apply this to an example. We start by assigning node voltages. Here we have V1 and V2. And when we talk about these node voltages, we're referring to the voltage across these branches. That's because those branches are between our node and reference node. So for node 1, we have 3 currents. Because the current direction of I2 is unclear, our signs can become confusing. The easiest way to keep track of your current directions is to make all I values exiting the node. This is possible because if we have V positive and V negative the wrong way around, the result will be negative, which works because they're on the wrong side of Kirchhoff's current law. So, for node 1, we have the sum of currents is 0. I1 is a current source, so there's no equation for it, we just remember that it's negative. So, using this process from before, we have this, which simplifies to give us our first equation. For node 2, we perform the same steps. And now we have our second equation. This part depends on your maths knowledge. There are a few ways to solve systems of equations. For this I use Cramer's law, which gave me V1 equals 17.78 volts and V2 equals 11.94 volts. Cramer's law is another story for another time, but if you want to pause the video, it goes a little something like this. Thanks for watching.